So this page, pretty simple, but all it is on the top, you can see what are my previous purchases, same previous purchases that I had in page one. And then I have these different recommended products for me. I think one thing to keep in mind with this example, again, not something that would be representative of real UI where someone's clicking like, tell me why this is recommended to me. This would probably be something that would be kind of generated ahead of time and stored and then just surfaced to the user. And I think the Batch API could be a really good way to do that at scale offline. We can talk a little bit about that later. But you can see here are the different recommended products for me and the score and why they're recommended. And when I click on generate explanation, what's going to happen here is it's going to take the product itself, it's going to take information about me, and it's going to have some sort of guidelines around what it should say, the length, the tonality, etc., to generate this explanation. So I'll try this vacuum cleaner to start. I generated it for this one, and you can see it tied in a few different things that I've already purchased to that recommendation. So you can control, how explicitly you want the model to say like specific items you've purchased in the past, or just use that information to generate a personalized recommendation. That's something you can kind of control in the prompt. But I think this is a really good example of like a difference between that screenshot I showed in the slides where it just was these products without any sort of explanation. And now these products that we've used the model to generate this more engaging explanation of why this product would specifically be great for me. So think of this again, I think the LLM is the last mile is a good way to think about this type of use case. Awesome. So we'll dive into the code now and see what this looks like. It's pretty straightforward, but there's really two main functions that I want to call out here. The first is on the recommendations themselves. Similarly to the list of previous purchases, I'm hard coding this just as to show an example of something that the model is not doing. So you probably, or you maybe have some sort of propensity recommendation score that you're doing already. Think of this like these being dynamically generated for a user. So I can see the product itself, the category, and then like what's that like score, the output of that propensity scoring algorithm. What's really happening, and when I click on that button to generate the explanation, this is what is actually being run under the hood. Again, like I said before, this is something I'm doing in real time for the purposes of the demo, something that you could do offline and then just store and have available to the user as they're interacting with your website or wherever they're interacting. You can see here the prompt, again, your product recommendation assistant. We've given what's the product that was recommended, what was the category of that product. You can give any sort of other information that you want. Give some information about what the user previously purchased, and then give it some guidance in order to get the user excited about it. You'll notice I have pretty limited here in terms of like controlling the tonality. You can both through the prompt here control that tonality a bit more, and there are other techniques that you can use, which we'll actually get to in the customer example, to really make this output feel like your particular company guidelines or branding. So those are the two main functions for this example. Again, while it's pretty straightforward, like from a coding perspective, I think this can be a really powerful way to take outputs that you have from any sort of propensity scoring algorithm and make them more personable and approachable for end users at scale. The other thing I'll call out here, I'm using 4.0 for this. This could be something that you could use 4.0 Mini for or other models as well. So those are the two main kind of code walkthroughs and demos. Again, you have access to this in the repo, so you should be able to kind of spin this up yourself, play around with it, and dive into the code a bit more on your own. So with that, I'm going to quickly jump back to the deck, and we'll talk a little bit about where we've seen this be successful. Cool. So to recap here, I'd say we've talked about two things. We've talked about how do we use LLMs on the input side of things, more on the search. When the user search isn't a great fit for the product catalog, how do we, one, better match that search to the product catalog itself using LLMs, driving more personalized experience? How do we inject user information into that query to make it even more enhanced from a personalization perspective? And then how do we use semantic search to better drive the search experience beyond just pure keyword search? And then on the right-hand side, we talk a little bit about outputs. If you're doing a lot of this type of work today, where you're generating these recommendations, but it does feel a bit like a black box, using our models as the last mile, given that output, how do we make it more approachable? How do we describe it to the user and get them excited about purchasing the product, as opposed to just having a product surface onto the website? And if we talk about the specific ways that we did these things, that query expansion, we took that more ambiguous query, I want to build a deck, and we transformed that into a list of relevant categories and an explanation for why those categories are relevant. So then me as a user, I can dive into the right category and I know what are the things I have already, what are the things I don't, and that's already incorporated in the explanation itself. Here, what we've also done on the query augmentation side of things is we've injected those previous purchases in order to make those explanations more approachable, and also to remind the user about things that maybe they already have that complement some of the purchases that they're going to make. So that previous purchase is just one example. Any information you have about that user that could drive their spending habits could be put into that prompt and then used to generate that sort of explanation. And then the last one on that side, the semantic search, you'll notice when I searched like something to chill in versus hosting a dinner party, those were not things that were necessarily like keyword matches for the descriptions of those items, but because the model better semantically understands the relation between the search and the embedded description using a similarity search, you're able to get better products that are surfaced based on the user's query, regardless of whether it's something very specific or something more ambiguous like hosting a dinner party. Then on the right-hand side with the outputs, we also used the LLM as the last mile, where we had that hard-coded propensity score and different products that were recommended to me. And we used the model to generate in real time an explanation for each of those recommended products, incorporating user profile information and past purchase history. So again, making those really engaging and making them better explained to the end user. So as far as where we've seen customers, I've had a lot of different conversations with customers in retail and media and a variety of different places. I think this customer story with Indeed is a really good example of this in action, where they used our models to improve their invite to apply feature by adding personalized, approachable language generated by a fine-tuned model. So their primary goal is, instead of matching like an ambiguous search, like I want to build a deck to a list of products, it's more like matching users to different jobs. But maybe the initial search isn't the right way to do that. So they saw by enhancing the description and enhancing what actually comes back from the model, which you can see some examples on the right, they saw a 20% uplift in applications and a 13% uplift in downstream success by just using the models to kind of personalize that outreach of that invite to apply. I think an important part about this is they also, because they used a fine-tuned model, they're able to better control for tonality and other pieces. In my demo, I just put in the prompt, be concise, be playful, to drive that tonality. But there are a variety of different techniques you can use to really make sure it fits your branding and your tonality. And fine-tuning a model is an example of a technique here that Indeed used. So yeah, this is on our website, so feel free to read more about the use case there. But again, I think a really good example of using the model as that like last mile explanation to the end user to make it more approachable and a proven success of it actually driving an uptick in clicks and downstream success as well. Awesome. So there are a few different best practices, I would say, that are important to think about if you're considering using LLMs in some sort of customer-facing or some sort of recommendation type of workflow. I think one thing to keep in mind here, our goal here is not to give you necessarily like UI advice. On that demo, the like multi-click search experience, the like generating explanations in real time, those are more just examples of the functionality as opposed to the user experience. But here are some things that when I've been talking to customers have come up that I've advised them on. The first is like ensuring business value. I think you want to make sure what you're building is actually like solves a problem and it drives a new valuable experience. We've seen people build these sorts of like a shopping assistants or things like that that maybe haven't had the sort of business justification backing. So you want to make sure that what you're doing actually enhances what the user is trying to accomplish at the end of the day. And conventional search works well for a lot of different use cases. So just because we're kind of showing some examples here doesn't mean it's always the right fit for a customer-facing website or some sort of product search. It really depends on understanding the user and understanding the outcomes you're looking to drive. The second piece is intelligence first and latency optimization. I think especially for something that's like customer-facing, having really good latency is a key factor because customers have a pretty low tolerance for slow latency. But what we've seen this actually go sideways sometimes is people are optimizing for latency really early in the process without actually validating that the model can do what they want. So then they optimize, spend all this time, and then realize that the user experience that they're driving, isn't necessarily one that works well with models or isn't really like an LLM problem to begin with. So then there's that kind of like wasted effort upfront with optimizing for latency. So I'd say keep that in mind as you're starting to build these out of make sure the models can actually do what you hope they can do. And then there are a variety of different techniques you can use to optimize for latency after the fact. Things like using smaller models, distilling a model, moving from online to offline and using things like the batch API to pre-process a lot of these recommendations, using prompt engineering and modifying your prompt to leverage things like prompt caching. There are a lot of different techniques you could potentially use there. We have some guidance on optimizing LLMs for latency that is definitely would recommend reading as well. But that's just something to keep in mind is make sure the models can do what you want them to do, and then use the variety of different types of techniques that we have to optimize for latency. The last thing here, and I think this is a really important call out where we've seen customers come and try to kind of do entire recommendation systems with LLMs is understanding what LLMs are good at versus more like narrow or traditional ML. LLMs are not a replacement for these sort of recommendation systems that are designed more to analyze large amounts of data. LLMs can kind of enhance search on the inputs as well as on semantic search. They can be that last mile delivery on the outputs, but all of these sort of techniques to analyze a bunch of data, come up with propensity scores, have been a really good fit for traditional ML for a long time and just complement LLMs nicely. So I would say pairing them together is a really powerful experience as opposed to just doing one or the other. Awesome. So those are really the main things I wanted to walk through today. I know we have a good amount of time left. I think for the remainder of the time, we can do more Q&A. The other thing I'll call out is we do have some resources in this deck that we'll be happy to share with you after the call.
All right. Well, thanks, Max. That was amazing. I have to host a Christmas party next week and I don't have any decorations. So I wish I had something like this handy to just get a list of things I need to buy. So I can definitely see these patterns being super useful in especially these retail use cases. We've had quite a few questions come in, so let's just go through them one by one. This is actually an interesting one because we didn't cover it in too much detail in your demos, but I think it's like a key component of this whole experience. The whole approach to data enrichment and embedding. We've had a question basically trying to figure out how do you actually get your data, your catalog in a place where it can actually like map the characteristics of a particular object.
Mhm.
So the specific question is like, if I want to have durable outdoor seating options, how do I match that particular attribute to like a weather resistant material in my inventory or something along those lines, right? How do you go about improving or enriching the data that you have to better work with your semantic search?
Yeah, it's a good question. I'd say a few things. One, on the data enrichment side, traditionally with search, there's been a lot of, you need to kind of have a very structured data set where you have like specific tags that you're filtering on or categories, whatever it may be. I think the nice thing with semantic search is really you just need to generate like text, unstructured text that describes the item. And then that matches nicely with more broad semantic search. So in the example that I was showing before, like those are just kind of loose descriptions. But then when you're doing the similarity score matching, you leverage the model's ability to understand the user's query, understand the description, and do the proper matching from there. So I'd say like, it's a good question. I don't have specific advice
Yeah.
on like that connection, but I think it's important to think about the difference between like traditionally we've had these product category logs that need to be very structured.
Mhm.
And I still think that's very important, but there's this other piece of it of having this like unstructured high level description and then doing semantic search on that.
Mhm.
That can be really powerful for search type of use cases.
You could use Vision, right?
Yeah.
To generate those descriptions as well.
Exactly. Yeah, and that's actually what we did in the like dummy data set that you'll see in the repo. I created a product name and generated a Dolly image for each of them, and then put that through the vision model to generate the descriptions with some information. So
Very cool. With the Indeed case study, there's a question specifically about that. Do you have a sense for like the corpus of like just the general corpus of tokens they were working with? Or in general, like with some of these customers that you've spoken to, like what is the general size of some of this information that they need to sort of build into a scalable system?
yeah, it's a good question. I don't really have a good sense for like the exact level of scale, but I'll say like offline is definitely your friend for a lot of these. The combination of using like the batch API and using something like a fine-tuned model or a distilled model can really keep the like token costs or the costs down more generally. And then storage is cheap. So once you have those descriptions, then storing them and surfacing them. So don't have a good answer, but we'll just promote kind of the batch API to do a lot of this work as well.
On that note, specifically around, because you mentioned fine tuning, we've had a question come in around how do you actually get the model to be more confident in its recommendation? This user has a situation where they're sometimes struggling to get 4.0 to make a confident recommendation. It just outlines the pros and cons of
Yeah.
things. Is this something you can do with prompting? When does fine tuning come into the picture? Love for you to speak to that.
Yeah, I think it kind of ties into like what I've seen with evals as well, where if you're doing like a numeric ranking or something, it kind of gives very similar numbers a lot because it can see like the pros and cons of each. We have a good cookbook on this, on like the eval side of using more like categorization as opposed to like a numeric ranking, and that using that as the thing to judge on. So I think that's something that I would look in. I think it's evaluating LLMs with Brain Trust, I believe is the name of the cookbook. But I think that one gives a good example of using like the LLM as the judge and putting it into different like categories as opposed to doing like a numeric ranking, because then the model can kind of see pros and cons of each. So it's like kind of using a separate model call, understanding the different rankings, and then putting that back in.
One question on data enrichment. Have you seen any benefits to basically using JSON data to structure the corpus with tags and more structured information as opposed to maybe having like a unstructured sort of prose description of each item?
Yeah, I think like there definitely can work well in tandem. I think even in that demo, there's a good example of that where right? I did the search. It first gave me the categories, and then I did the semantic search within those categories. If I had just immediately done the search without doing filtering on the category first, that would have given me a different list of items that maybe I actually wasn't that interested in. So I'm kind of using the combination of the structured data and like the JSON of the categories with the unstructured data of just the general description. So I would say there's definitely place for both, and it's important to have both the kind of structured side of things as well as the unstructured. And then you can also use the model to help you figure out gaps in your structured data. We've seen some good success with that, especially with our reasoning model to understand the data, figure out where there are different gaps, and then kind of suggest improvements.
This next question is interesting. I think it also like hints at a topic that we didn't quite touch on, but I think is important around like guardrails on model generations. And not specifically in the context of safety, but more in the context of like, how do you get the model to not generate something that's not in your inventory, right? Like you don't want it to maybe just go off and try to please the user and come up with something that doesn't exist.
Yeah.
So what are some ways to mitigate that?
Yeah, it's a good question. I'd say a few different things. One technique I did not use at all in this demo is function calling. So instead of like giving the model a list of different categories, we actually have the model like but surface that it needs to execute a function and then go query a database for those products. So those products are coming back from the function call. That's a potential practice you can use. The other thing which I showed a little bit in the demo was like on the structured output side of things to prevent it from coming up with different categories and hallucinating, using structured output to give it, here are the different categories you can choose from. Then one, I didn't need to include that in the prompt at all. I just said, you have different categories, use them. So that kind of helped on the token side of things there. And then two, reduces the risk of hallucination directly from there. Yeah, those are the two things I would say.
Cool. Maybe this question you can just answer by going to the relevant question in the code, but I think this user wants to just get a sense for how you combine semantic search with the recommendation score. So I think it might help to just show that piece in the code. I know.
Yeah, absolutely.
Yeah.
Let me share the right tab again. So as far as when we're thinking about like the propensity recommendation, I guess the semantic search and the like propensity recommendation are actually two different like experiences in this demo. The first, you can see like we have the past purchases. What we're doing is we're feeding that into the model. And we're basically giving it, here are the list of the past purchases, what this user's had. And in this prompt, we're telling it what those past purchases are down here. And we're just giving a single shot example. So we're doing this pretty much all in the prompt, or we're passing in different inputs. You'll notice for this, it's just the user's query, which is like dynamically coming from the Streamlit app and their past history. But you could make this even more generic, just have like user profile here, and then you're just passing in like information about the user and letting the model figure out what's relevant and what's not. As far as like the generating the explanation of the recommendation, if that was more of the question, all we're doing here is we have this list of recommended products that you may have your own system that's generating these scores. The model actually is not doing anything with generating scores here. It's just using that as an input in order to generate the explanation. So we have this score, and then we have this model, this prompt. Basically, all we're doing is we're telling the model, what was the product that was recommended to the user? What was the category? What is the person purchased in the past? Combine all of those and get the user excited about this particular product. So it's just a single call here that just takes those as inputs. And this is all with the assumption that you've already generated that propensity score using another technology outside of OpenAI.
And that's the bridge between traditional ML and
Exactly.
LLMs, right?
Yeah, we've seen it the model, we've seen good success with LLMs as this like last mile. This is a recommendations use case, but even across the board, if you have different like intelligence systems or other things that you're doing, putting the model as like this layer on top of all of the traditional ML you're working just to explain things to users, whether those are your customers, whether those are like internal employees. We've seen a lot of success with that sort of combination.
Mhm. On that topic of guardrails, there's a follow-up. If the catalog items are out of stock, is there a way to handle that other than simply eliminating it from the output list? Maybe like with function calling, maybe there's a way to like have an intermediate step where it goes off and checks if the returned
Right,
item is in
yeah,
stock,
I think
right?
that's something that would be like handled somewhere in your code offline, whether it's like gathering the current inventory, getting the list of products that are available, and just providing those to the model. If you just give the model the list of products without giving it the information of the inventory, then the model won't be able to tell. But if you're handling that somewhere in your code before it actually hits the model, that would probably be my recommended practice here.
Awesome. Yeah, and then there's a follow-up that's around the propensity score. It's not modified by the intent of the search query, right? Like it's
Correct. Yeah, those are
separate.
two
Yeah.
kind of separate things here. Yeah, that's an interesting one. And if that's something that you are doing yourself, that can be then like fed back into the model. So I guess these two are like isolated experiences in this demo, but they don't have to be for your application or for how you're doing things.
Awesome. I think that's it in terms of questions. Unless you have any more in the next couple of minutes, we'll wrap up here and share the recording with you along with some of the resources we presented. We're so glad you could join us for our final build hour of the year. We'll see you again in the next year, and happy holidays. Thanks for joining.
Yeah, thanks everyone.